In this video lesson, I'll explain what the logarithm function is and how it works. So before we learn about logarithms, we always learn about exponents. So if we have y equals 10 to the x, an example of an exponential function, then this function, we can sort of make a table which takes values of x to values of y. So for example, x equals 0, if you plug in 0, you get 1. And you can check these all on your calculator very easily. And 10 to the 1 is 10, and 10 to the 2 is 100. So you can sort of visualize the function as taking values to other values. Now the question here is of the reverse. What if you want to start at 1 and go back to 0? And that is what the logarithm is. So if we take the logarithm of y here, then we will get x, meaning the logarithm is the return arrow. So if 1 was taken to 10, then 10 is taken to 1. If 2 got you 100, then 100 gets you 2. So for example, if we write log of 100, we'd get 2. And in this case, notice it's log base 10 of 100. And that is the same as 10 squared equals 100. So the logarithm does the exact opposite of what the exponent does. If you're given a base and the result of taking a power, it'll tell you which power you took your base to. So log 10 equals 1 because 10 to the 1 is 10. Again, it's very easy to remember it as sort of the returning arrows from an exponent function. So now let's take a look at some more examples and some more explanation. In a sense, the logarithm is flipping the x and the y in an exponent function, and I'll show more what this means with these graphs. So on one side we have the graph of y equals 10 to the x, and on the other we have y equals log x. And in the middle here, I'm just sort of sketching their overall shape next to each other, as if they were on one graph. So what's important to notice here is that these graphs are actually mirror images. And I'll show this in more detail in just a second. So if you take, for example, where the points intersect the y and x axes, those are perfectly flipped. I'll show you what I mean in just 1 second. So here I'm just drawing this dotted line. It's actually the line of y equals x, but that doesn't matter that much right now. And we get the logarithm by flipping 10 to the x over this line. So if I just sketch right now the mirror image of 10 to the x, then I'll get the logarithm function. Now I'm not perfect at drawing, so obviously it looks a little bit different, but I can show you the drawing made by a computer, and this is what it looks like. So as you can see, on top we have 10 to the x, and on bottom we have a log of x, and they're perfect mirror images. Now this is why the line y equals x is important. When we flip around this line, we're actually switching x and y. So really the best way to think of it again is the logarithm returns the values backwards. It does the opposite of what the exponent does. So really what this means is, again, if, for example, we have 10 cubed equals 1000, that means log of 1000 equals 3. Because the power we took 10 to get 1000 is 3. It's exactly the reverse arrow. Another slightly different example. Let's say we have, I'll take 4 to the third. So 4 to the third, you can calculate it. It's just 64. And if we take log base 4 of 64, we will get 3. Again, because 4 to the third power is 64. So whenever you see a logarithm, you should ask the question, to what power do I take this base to get this number? To what power do I take 4 to get 64? That power is 3. To what power do I take 2 to get 32? Well, it's 2 to the 5th, so I take 2 to the 5th power. So log base 2 of 32 is 5. And notice how exponents have bases, logarithms also have bases. These bases are the same. So anyway, that is about how a logarithm works. It's just the reverse, the backwards version of the exponent function. Thank you for watching this video lesson. I hope it helped.